All right, so in addition to being able to convert from one notation to the other, we need to be able to evaluate an expression and simplify it without the use of a calculator. Okay, so all of these are going to have whole number answers. Let's go ahead and see how they work. The best thing to do is to rewrite it in radical notation because we know how to find the exact value of a radical. So this radical, the index is a 2, and the exponent is a 1. Okay, that means I'm really just looking at the square root of 36. Well, we know the square root of 36 is 6, and we are finished. Easy peasy lemon squeezy for problem number 5. Okay, number 6 I'm going to do in 2 different ways. First option, write it as a radical. This is a cube root of 8 squared. Okay, so that is the cube root of 8 squared is 64. The cube root of 64 is 4. Not super difficult, as long as you know how to convert to the opposite notation. Now there's another way to do this, and this other way is going to help us to do number 7. I can write this as the cube root of 8, but instead of putting the squared here, I can put the squared on the outside. Okay. Now in doing that, I can now figure out, well, what's the cube root of 8? Cube root of 8 is 2, and then 2 squared is also 4. So it really doesn't matter what way you do it, they give you the same thing. So Ms. Mara, why on earth are you showing me 2 different ways to do the same problem? Well, here's why. Let's take a look at number 7. If I write that as a 5th root of 32 cubed, and I do not have a calculator, I don't want to sit there and figure out 32 times 32 times 32 and then try to find the 5th root of that. That's a number in the thousands or 10,000s. No fun. So instead, I'm going to move the exponent to the outside, and I'm going to figure out what the 5th root of 32 is. Now, the 5th root of 32 is just a 2. And I can do 2 cubed without great difficulty. Way easier than trying to figure out 32 to the 3rd power and then the 5th root of that ginormous number. Okay? Let's take a look at a few more examples. Okay. Problem number 8. The first thing I see is a negative exponent. We don't like negative exponents, so this means move me to the bottom of a fraction. So this is really 1 over 81 to the 3/4 power. Make it to the positive power instead. And now I just need to write it as a radical. This is the 4th root of 81 to the 3rd. I don't want to figure out 81 to the 3rd, so I'm going to move the 3rd to the outside. The 4th root of 81 is 3. 3 cubed is 27, so I get 1 over 27. Okay, so by moving the exponent outside of the radical, it makes the problem a lot easier to do without a calculator. All right, number 9 is a little bit tricky. You're going to see this 2 outside and think, hey, can I just distribute it? And the answer is no, because of this subtraction sign right here. This is a binomial squared. That would be a FOIL or a double distribute problem. I don't want to do that. That'd be crazy. So let's figure out what 9 to the 3/2 power is. Let's figure out what 16 to the 3/4 power is, and then work it from there. Okay? This is a numerical expression, which means we need to do order of operations, or PEMDAS, or please excuse my dear Aunt Sally, however you learned it. Simplify inside the parentheses to a single number first, then deal with the exponent on the outside after the fact. So 9 to the 3/2, that's the square root of 9, cube the result. So this is 3 cubed, which is 27. Okay, so this is a 27 right here in the parentheses. Now I want to figure out 16 to the 3/4. That's the 4th root of 16. And then cube that result. 4th root of 16 is 2. 2 cubed is 8. So there's an 8 here. All right? So now up top, 27 minus 8 is 19. And I can figure out 19 squared. 19 squared is 361. And yes, it would be fair for me to ask you to square a double-digit number on a test without a calculator. So be prepared for that. All right. Number 10 down at the bottom. Comparison between the two. One of these, the negative is stuck with the 125. The other one, it is not. The first one is the one where it is not. This is negative 1 times 125 to the 2/3. When the negative is in the parentheses, like you see over here, it's stuck with the number. That's what the parentheses are saying. This number needs to stay as is. So I'm going to make this negative 1 times. This is a cube root of 125. The exponent is a 2. And I'm going to work it from there. Cube root of 125 is 5. 5 squared is 25. Negative 1 times 25 is negative 25. Final answer here, negative 25. Versus the parentheses. I do the cube root squared. The negative 125 has to stay negative 125. Cube root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is negative 125. Square it, and you get positive 25 for a final answer. Okay? So that's evaluating numerical expressions that have rational exponents involved.